All right, since the video I made about me doing full steps but sideways somehow went viral for no reason, here I'm going to review the paper by Adam Petway about the mechanisms of Achilles tendon rupture in NBA basketball players. So very, very current, especially given what's happened in the last season. However, this paper was published in 2022 by the Journal of Applied Biomechanics, okay? So the gist of this paper is a video-based analysis of in-game injuries. So this is actually super important. We like to go for a concept called ecological validity, meaning the things we're studying, we're describing, we're trying to understand are happening in the context that actually matter. So in the case of injuries in basketball players, a lot of the injuries in terms of like sports-specific movements are occurring in a lab in more controlled scenarios because that's just what's available to the researchers. But being able to see things in game during actual competition, that's a great advantage, okay? So here, I'm just going to go through this paper. Now, the introduction it's fairly broad, fairly general about, the risks and values of the risk of an Achilles tendon rupture in the sport of basketball and the value for looking at it. It's pretty self-explanatory. So what I wanted to focus on right away is the methods, video analysis, okay? And really, it's just eyeballing. We are eyeballing and digitizing, meaning we are using our mouse and pointers to point on the screen where we expected the body to be. And in order to use that to generate specific angles. So here we have three viewers with expertise in sport and basketball. And then they used it on the computer. As expected, they took the measurements at the moment of end range ankle dorsiflexion of the back leg. And here's one of the figures that shows it. And they were asked to judge whether they had possession of the ball or not. That's very easy. But interestingly, there are key variables of interest here, okay? So there are key variables of interest, the range of motion of the ankle of the back leg, that makes sense. That of the knee and hip of the injured leg, yes. And the hip and the knee of the non-injured leg, so that's the front leg, as well as the hip trunk angle. In that case, it's the hip flexion, or really the posture, as we like to call it. Three joint angles were obtained for analysis, including the ankle dorsiflexion, so that's basically the gap between the foot and the shank of the back leg. Knee flexion angle, so the angle of the knee here. And lastly, trunk angle relative to the hip, so that's the posture angle. And they say that these angles were of interest because it was present in all 13 instances of the time of injury. So there were obviously more injuries, but due to practical concerns, they were able to look at 13 videos. And they used Excel. There's a running joke when I work with the Marlins about, the devilness of Excel. But I have, in my most recent research, used Excel as well, because sometimes it's just damn quick. When you do the column mean, column standard deviation, than it is to code, It is what it is. Okay, so here's the juice part, right? I mean, the angles values themselves, they're great for reference values, but it doesn't serve too much meaning here. But what's really interesting is the full step. In all videos analyzed, the athlete took a backward step with the injured limb, well outside the base of support without any displacement of the body center of mass. Okay, so I really wanted to dig in here. So let's start with, why is there a full step to begin with? What is the purpose of the full step? The general framework that I was trained to think about movement is that you start with the mechanical objective. Like what are we trying to accomplish here? The goal is to go forward. Sounds simple, sounds dumb, but that is the goal. AKA, we want to make sure we want to accelerate our body center mass forward. Thinking back to Newton's laws of motion, what needs to happen in order for us to accelerate forward? Well, we need to generate forces that are directed forward as we push against the ground. Okay, so now we know the goal is to go forward, and that is accomplished through application of forward ground reaction forces. What is the best way to do that? Well, it's to make sure we have our limbs that's aligned with the forces. Think about a sprint start, how we are pushing backwards, and we have the very deep shin angles, right? The idea of the shin angle is essentially saying we want to make sure our limbs are aligned with the forces we want to generate. And that's what's best to help us get where we want to be, to help us accomplish the mechanical objective of this forward acceleration movement. So really, the full step, instead of stepping backwards, my perspective is that it's just simply the quickest way for you to access a large amount of ground reaction forces in your intended direction of travel. If you want to accelerate forward very quickly as you can, when you have the ball in a blow-by scenario, then yes, you want to step backwards. If you want to rapidly change your direction side to side, you want to put your limbs side to side outside of your body center of mass. Okay, so to me, the full step per se, I mean, also this was acknowledged in the paper, but I just wanted to, explain this a little more. But here it said that, the athlete took a big step without any displacement of the body center of mass. Well, if we think back again to Newton's second law, in order to move and displace our body center of mass, force must be applied first. So obviously, if you take the step and you haven't had the chance to apply much force before Achilles goes, yeah, your center of mass is not going to be moving, right? That's just Newton's laws of motion. So that's just sort of breaking down the full step idea here. Now, here's generally what the posture looks like, and it's described that, the athlete reaches a very, very shallow angle of ankle dorsiflexion, meaning there's pretty much not a lot of structures here that's resisting this motion, because if we look at the anatomy, this is a very rough anatomy, but like you see how the Achilles tendon sort of inserts at the calcaneus bone and then it's like connected to the calf muscles. If it's all connected and there's tension along it, it will resist the dorsiflexion movement. And when you contract and the entire area shortens, that's when you would generate plantar flexion moment and movement. Okay. So really, this is describing almost the aftermath, right? This is kind of similar to how the ACL goes before you hit knee valgus. This is kind of similar where the structure goes and we see the form. The structure of the Achilles goes and we see the form of the extreme dorsiflexion. So this is describing, I see it as describing what's happening. As for the front knee angle and the posture angle, I see it more as a direct manifestation of the mechanical objective of trying to go forward as quickly as possible in a blow-by scenario. These are the best athletes in the world. But even if you aren't as athletic, right? If the goal is to go forward as quickly as possible, you are going to see these things. Okay? So here they also mention about the outward turning of the foot. Now this is where the methods really come to matter, because it's actually very difficult in a 2D case to fully annotate. Like let's say if you imagine here, if I want to try to annotate where the heck the endpoints of the foot is, I have to estimate, where I think the heel is, where I think the toe is. You might not have the consistent angles to really, this is a 2D based analysis, I assume. But even the 3D based analysis of different camera angles, it's going to be very difficult to make out where the tip of the toe is. Obviously, it's going to be different for different shoes. And then if you really want to get a toe angle relative to internal external rotation to get a torsional stress, it's very difficult because you have a point at the hip, point at the knee, maybe a point at the ankles, the heels, the inside, outside of the toe. How consistent can you be camera angle to camera angle? How consistent can you be athlete to athlete, right? It's very difficult methodologically. So usually when it comes to these kind of analysis, and even with more advanced markerless motion capture, I generally don't trust angles that's outside of the typical sagittal plane. Obviously with a classic sagittal plane, you can get pretty good, but when it comes to the foot turning in or out, it's very difficult to get it exactly right. You can tell directionally, right? My old boss Scott would like to say, "Oh, you might not trust the accuracy of the measurement, but you can still gain information of directionality." So yes, you can tell if it's rotated in or out, but the angle values are very difficult to make out. And this is what's acknowledged here as well. And it says beyond the scope of this paper. Cool. Now this is very interesting about the implications and suggestions from this paper. So he says it's important to generate increased Achilles tendon stiffness during the full step movement to avoid this end range dorsiflexion. But the thing, my perspective at this moment in time is even if you have increased Achilles tendon stiffness by contracting your calf muscles as hard as you can and not dropping your heel, tension is still going through the Achilles, right? So to me, the idea is sort of about whether or not it's less about whether or not you want to maintain active stiffness or not. It's really about, I mean, okay, it is partially about that. My point is when you have a sort of like slacky and when you cannot handle the amount of stress, maybe there's more magnitude of load going through the Achilles when you're aggressively dropping your heel versus if you're trying to hold it isometrically at the ankle, aka stiffness, because maybe your calf muscles will go first. To me, that's sort of almost like the mechanisms of like you pull your calf first, your calf is less capable, and then you sort of you let it slack, and then your calf isn't so your calf isn't the limiting factor of how much force is going through the backside of your lower limb, and therefore your Achilles experiences a higher magnitude of force. This is obviously just my speculation, based on the link, I guess the kinetic chain at the backside of the calf. Okay. And training effective movement strategies for the full step. And to me, this is where the idea of the T step comes in, where you sort of, again, you pre-outwardly rotate your feet. I think I'll try to make a demonstration video because that's something I experimented with. And basically, the idea is when you have your full foot planted, you theoretically cannot go into that much more additional dorsiflexion. So your Achilles does not have to take on as much load through the rotation of the foot in the T step relative to the full step. It also shifts the load from being almost largely through the Achilles to being shared by some of the lateral ankle ligaments. Okay. So it's really a load distribution strategy. If you want to achieve the same acceleration outcomes, you're going to need the same amount of ground reaction forces. But what's different is when you change your body's posture or really orientation relative to those forces, you're going to change the tissue loads experienced by different tissues because of where they are in space anatomically relative to the forces. Okay. And there's some mention about the age-related changes to Achilles tendon. Adam covered this in greater detail with Jake Torres' podcast quite recently. That was bloody brilliant. Loved it. Also, Adam, please check your mailbox. I sent you a couple of emails. Okay. So lastly, cumulative. Okay. Not too much to go over. Obviously, if you have too many cumulative load from earning millions in the NBA, you might be more at risk. But then again, if it's always a matter of like the load versus the capability, right? Whenever one of them goes up too much relative to the other, you're gonna be in trouble. So nothing you should. Okay, here it says the limitation of the study. So only 13 Achilles tendon rupture. So that's the problem with these catastrophic injuries. You're always going to be limited by the sample size. So, I don't see it as much of a knock compared to other studies. Especially, I love things being ecological, being studied in their natural habitat, at least to the best of the researchers' abilities. Secondly, the two-dimensional video analysis, to me, that is one of the more important methodological limitations and inconsistencies. I know there's ways to calculate the amount of the reliability of the process that was not presented here, I don't believe. But it's literally just eyeballing with a digital mouse. So, you know, limitations aside, at least the findings are pretty clear and pretty consistent across each of them. I think it's just important to point out the causality and the relationships between different phenomena that are observed, right? What's really driving this movement and what's happening as a outcome measure of the Achilles going versus what's actually causing it, aka, do you have big dorsiflexion because there's nothing holding you back or nothing holding your foot back? All right. So I hope you enjoyed this. I think it's week 3 of Writing Wednesday. Again, I've somehow always filmed this late at night, at least 7:30 today. And make sure to do your calf raises and think about your full steps and don't be too scared because damn, I am scared of the Achilles going through. So, I have been maintaining active stiffness and also not playing in full competition while fatigued. I hope that will help me. So yeah, see you next time.